Okay, so first question we're going to look at is going to involve radicals. Okay, what we'll do is we'll describe the transformations and then we'll sketch it. Okay, so first, how many transformations are happening in this one?
4.
Yep, there's 4. So we're going to describe each one of them. And what number would we focus on to describe the first thing that's going to happen? Yep.
Is it the horizontal shift left 4 units?
Yep, so that's the first thing. Horizontal shift, that's going to be left 4. Okay, what's the next number that we're going to focus on there? The 2. Okay, now we got to be careful because that's a horizontal, you could say it as a horizontal stretch by factor of, and this is where you have to be a little bit careful. What's the horizontal stretch by factor of how much? Yep.
1/2.
It's really 1/2. The bigger you make that number in front of x, the more compressed it's going to get. So technically this is compressing by a factor of 2. You could word it that way. I usually word it as horizontal stretch. Okay. All right. So we got the 4, we got the 2. What's the next number?
The 5.
The 5. And what transformation is that going to be?
It's the vertical stretch.
Vertical stretch by how much?
It would be 1/5. Or it would just be like 5.
That would just be 5. So the vertical is just what you see is you don't reverse it. Yeah. So vertical stretch by factor of 1/5, factor of 5. And what about the -3? Yeah.
Vertical shift down 3.
Yep. So shift down 3. Okay. So that's how you describe all of the transformations. Would this particular graph have a start point or center point?
It'd have a center
Yes. Why would it have a center point?
because it's odd.
Right. It's an odd root, so that means when you graph it, it's going to go left and right. So it has a center point. How do I find the x-coordinate of the center point? Yeah.
You set what's in the square root to 0.
Yeah, so set that radicand equal to 0. And we solve it. We get that the center point has an x value of -2. And what about the y value? If you fill -2 back in for x right there, what will you get for y? Yeah.
0.
So if you do that whole thing out, what would y would come out to 0?
Oh, I just did it under the
Yeah.
-3.
-3. Yep. So that should be the coordinates of our center point. -2, -3. Now, since it's an odd root, we said that it's a center point. I got to check points on each side. What's the quickest way to get some more points on that graph? Yeah.
Using the table on the calculator.
Yeah, so let's use the table. If you want, you can check the one you already did to make sure it's right. So we had -2, -3. Let's see. Yeah, -2, -3. And I would pick 3 points to the left of the center and 3 points to the right. So maybe -5, -7, -10. I'm going to have to estimate a little bit because we're going off the graph. And let me go on the other side. Let's do 0, 5, and 10. Yeah, those, 10. Those are more okay. Okay, those I can do. Some of those other ones are going to go off the graph. All right. Let's just bring that down. Okay, so we've got -2, -3, we did that. -5, -12. 2, 3, 4, 5. So my graph goes to -10, so it's a little bit further off. And -10, we're at -15. So let's just go little bit more down than that. So I'm going to say that this part does something kind of like this. All right, now I'm going to get the other part. Okay. Actually, can I put that? No, I can't do that. All right, so we've got 0, 5. 1, 2, 3, 4, 5. We've got 1 that doesn't really help me much. I'm going to skip that one. 5, we've got 9. 1, 2, 3, 4, 5, 9. And 10, well, it's a little bit off the graph, but it's kind of estimated. So your graph does something kind of like that. All right, so any questions on how we sketched that or described the transformations? Okay. All right, so let's look at this one. So this is solving a radical equation. What's the first thing you always have to do when you're trying to solve a radical equation? This one's not quite ready yet. Yep.
Isolate the radical sign.
Yeah, you're going to isolate the radical. So in this case, what's next to the radical that we don't want? Yeah.
4.
4. And how would we get rid of the 4? Yeah.
Divide by 4 on both sides.
Divide by 4 on both sides. So that's gone. Leaves me with the square root of x plus 3 equals 2. Okay. Now is the square root isolated? Yeah. So that's good. That's by itself. Now, how am I going to get rid of that square root? Yeah.
You square both sides.
Okay, so we're going to square both sides. Square and square root cancels. Leaves me with x plus 3 equals 4. And when I finish that up and solve for x, what do we get?
1.
Yeah, we get x equals 1. All right. So any question on solving a radical equation? Okay. Okay, so let's take a look at a problem where we have to find the domain. So the first thing we have to look at is what kind of root is this? Is this an even root or an odd root?
It's an odd. Or no, it's even.
It's even, right? When there's no index here, it's always assumed to be a 2. So that is a square root, which means it's even. What's the type of roots that we have to be careful with the domain? Even roots or odd roots? Yeah.
It would be odd because you could go both ways in the graph.
Well, if your graph is going both ways, then that would mean your domain is what?
All of them.
All real numbers. So when you're dealing with an odd root, the domain is always all real numbers. You don't have to worry about anything. You can take the cube root of any number you want. But when we're dealing with square roots, we've got to make sure that this fits a certain condition. Okay, with even roots, you need to be careful with the domain. What do you have to make sure that the radicand is? And if it's not this, you're going to run into imaginary numbers. And we're not doing that.
Either 0 or a positive number.
Right. You need to make sure that the radicand is greater than or equal to 0. So now you solve that for x, and that's your domain. That'll give you all the values that are 0 or higher. So how would we solve that one? Yep.
I was just going to ask, so what is the radicand? Is it what you have circled?
Yes. Yep. That's what I circled. Okay, so what's our first step to solve that one? Yeah.
Subtract 1 from both sides.
Subtract 1 from both sides. That gives me 3x is greater than or equal to negative 1. Okay, and my last step.
Divide by 3 on both sides.
Okay, divide by 3. So that means x is greater than or equal to negative 1/3 if you write your answer as an inequality. How about if I asked for the answer as an interval? How do you write all numbers greater than or equal to negative 1/3? Yep.
So you have like a bracket and then 1/3 comma infinity parentheses. Or negative 1/3, sorry.
Negative 1/3. Yep. So that would be your answer as an interval. All numbers from negative 1/3 and up, including negative 1/3. So any question on finding the domain of a radical function? Now, what if I change this problem to plus 5? What would the domain be now? Yeah,
It wouldn't change.
it wouldn't change. This plus 5 would change your range, but it has nothing to do with the domain. It will not affect the radicand at all. Okay? So it'd still be the exact same answer. Okay, so we found the domain. Something else I want to find here is the y-intercept. How do you find the y-intercept of an equation? Yep.
Is that when you set x to 0?
You set x equal to 0, yes. Okay, so let's set x equal to 0 and see what we get. So we have the square root of, what's 3 times 0?
0.
0, and then plus 1. So we'd have the square root of 1 plus 5, and square root of 1 plus 5 gives me 6. So that is the y-intercept of that equation. If we want, we can double check it by graphing it and making sure it crosses the y-axis at 6. So square root of 3x plus 1 plus 5.
Okay.
Let's see if it crosses. Yeah, crosses, I don't know if you can tell, but it does cross up at 6. And I can see my domain is from negative 1/3 to infinity. Okay, so any question on finding the y-intercept there? All right, let's do another one with domain, because I have on here find the domain of radical. We should also be able to find the domain of rational. Let's do one of those. All right, let's start with x minus 3 divided by x plus 5. What would the domain be for that problem?
Domain is the x, right?
Domain has to do with x, yes. Yep. Yeah.
Is it negative 5?
The domain would be what?
Is it negative 5?
So the domain is negative 5?
I think so.
So that means you can plug negative 5 in and you won't have any problem.
Oh, no.
No. So, yeah.
Maybe positive 3.
So the domain is all the numbers we can plug in here and not run into any
Oh, so it's
problems.
so it's negative infinity to negative 5, right?
Mhm.
And then close parentheses and then like the connecting thing, and then negative 5 to positive. No, negative.
Any number not negative 5.
It's not negative 5 to positive 3, right? Because it can be between.
Right, you can, there's only one thing you're not allowed to do when you have a fraction. And what is that?
Divide by 0.
You're not allowed to divide by 0. So the easiest way to find the domain is to first tell me what you can't use, and then we can reword it into what you can use. So what can't you use? Yep.
Negative 5.
Right. You cannot use negative 5, but you can use anything lower, or you can use anything higher. So that would be your domain. So it's everything except negative 5. If they allowed you to use this symbol, you could, but I think usually I ask you to write it as an integral. Okay, so next one we're going to look at is solving a rational equation. And the first thing we want to do is get rid of all these fractions. So what would I multiply all 3 of those fractions by that could cancel out my denominators? Yeah.
X plus 2 times x minus 1.
Yeah, so everything gets multiplied by x plus 2, x minus 1. Now, we don't want to multiply out what's in red because it's going to cancel. Well, part of it's going to cancel. So let's cancel what we can first. Okay. What's going to cancel in the first fraction?
The x plus 2.
X plus 2. Second fraction?
X plus 2.
And the third fraction?
Denominator.
Yeah, if you multiply the two denominators you have together, you get x squared plus x minus 2. So this is that. Yep. Okay. Now we have to distribute what we have left. What do we get when we simplify the first fraction?
3x squared minus 3x.
3x squared minus 3x. Okay. Second fraction, and just be careful because if this was a negative, you're distributing that and that to what you have. But it's a positive. So 2x plus 4 equals, and what's the only thing on the other side? 5. Okay. So it's a quadratic, which means to solve it, we need to get it equal to 0. Yep. So we got 3x squared. What's negative 3x plus 2x? Good, negative x. And now we should bring the 5 over. What's 4 minus 5? Negative 1. Okay, so we could try to factor that, but I'm not sure that would work. Your signs have to be a plus and a minus, and two numbers that multiply to give you 1. You only have 1 and 1. So you would end up with minus 3 plus 1. That's a minus 2. That's not what I want. So that's not going to work. So what else can we do if we can't factor? Yeah?
Quadratic formula.
Quadratic formula. So negative b plus or minus, let's see, square root of b squared minus 4 times a times c all over 2a. Okay, what's going to happen when we subtract a negative number under the root? We're subtracting a negative. It's going to turn into a positive. So we can do that right away. What do I get for my radicand there?
1 plus 12.
Yep, which would be 13. That is your answer. Now, there's only two numbers we would have to check and see if they're extraneous. Negative 2, positive 1. Is that negative 2? No. Is that number positive 1? No. So, both answers that could have been extraneous, they didn't come up in this problem, which means as long as we did the quadratic formula right, those are the answers. Yeah.
So what would happen if it was negative 2 or positive 1?
If you got a negative 2 or a positive 1, you would have to cross that answer out and just say it was extraneous. Or if I had a spot on the test that said which answer is extraneous and which answer works, you just have to put it on the right line. Tell me which one works, which one doesn't. If it doesn't work, it will cause you to divide by 0. Okay, so this one they're asking us to find the asymptotes. They don't even tell us what kind. You got to know which ones you're looking for. The degree in the top is bigger than the bottom. That means you will not have what kind of asymptote? When the degree in the top is bigger, this can't happen. Yep.
Horizontal.
Horizontal, you will not get a horizontal. Okay? The only way you get a horizontal is if the degrees are the same or the bottom is bigger. That doesn't happen here. What's the degree in the top? 3. And the degree in the bottom? 2. That's a difference of how much? Difference of 1. That means we're going to have an asymptote that has a degree of 1. What do we call an asymptote that has a degree of 1? Yeah?
Linear.
Linear, and in more specific, it's going to be on like a
Y equals MX plus B.
yeah, it's going to be exactly. It's going to be like a slant asymptote. So let's do that one first. How do you find a slant asymptote? It's like the EBA. How do you find the EBA? Yeah?
You have to do division.
You have to do division. And once we do the division, the part that we're going to be interested in is the, we want the quotient. That's all we need. Can I use synthetic division to figure this one out? No. The bottom would have to be x minus a number, not x squared. Okay. So maybe you could adapt synthetic division to do it, but we've never done that. So we're going to do x squared minus 4. And what do I got to be careful about when I write down my terms on the inside here? Yeah.
There has to be one degree for each section.
Yeah, we want to make sure each degree is represented, or each power. 3, 2, 1, and then the constant. I don't have any x's, so what am I going to fill in for those? Yeah, I'm going to fill in 0x. It's just there to keep that column open for x's. That's all it's for. Okay, so now we're going to do 2x cubed divided by x squared. And what does that give me? 2x. Multiply it back out. 2x cubed minus 4x. That's why we needed that column open, because I just had to put something in it. And now what do we do with our columns? Subtract. 2x cubed minus 2x cubed is gone. What's x squared? Take away nothing.
X squared.
It's just x squared. And what about 0x? Take away negative 4x. 4x. And we can bring down the 5, but the 4x and the minus 5 at this point, they're not important because they're not going to be part of the quotient. They would be part of the remainder. Okay. What's x squared divided by x squared? 1. That is my slant asymptote. When we write an asymptote, it's normally written as an equation. That's not an equation, that's an expression. How would I write my EDA as an equation? Yeah.
Y equals 2x plus 1.
Right. Asymptotes are always equations. Okay, so we've got the EBA. We already ruled out a horizontal asymptote. We're not going to have that. What other kind of asymptote do we need to look for in this problem? Yes?
Vertical.
Vertical. How do you find vertical asymptotes? This actually relates to something we already did, but it's kind of the opposite of it. Yep.
Do you set the denominator equal to 0?
Yeah, you set the denominator equal to 0, and this time you want those values. If we were doing domain, we don't want those values. So the vertical asymptotes are kind of the opposite numbers of the domain. So what I would do is factor the denominator. Okay. This one just happens to be a difference of 2 squares. So I'm not going to need quadratic formula or anything like that. How does x squared minus 4 factor? Yeah.
X plus 2, x minus 2.
X plus 2, x minus 2. And what number would you fill into the first factor to make it 0? Negative 2. So vertical asymptote, negative 2. And what number would you fill into the second factor? Yeah. 2. So those are your vertical asymptotes, and that's it. Those are the only ones we've ever talked about. Vertical, horizontal, and then like an EBA. There's nothing else we could have. All right, and we've already have that on the calculator, so we can see we've got a vertical asymptote at 2. We got one at negative 2. And if I put the line 2x plus 1, hopefully it should look like our graph is getting closer and closer to it. That looks perfect. Okay, any question on that one? So now that we know in this one are two vertical asymptotes, or 2 and -2, I want to know what happens as I approach those values. Now, when you approach a number, how many different sides can you approach it from on a number line? Yeah? 2, the left and the right. So I want to know, let's say, as x approaches the number 2 from the positive side, I want to know what's going to happen to, we'll just call this graph f of x. As x approaches 2, and let's do as x approaches 2 from the negative side. What's happening to the y value? So remember, the positive side means if this is 2, you're coming at 2 that way. That's coming from the positive side. If you're coming at 2 from the negative side, you're starting on the left and you're approaching it that way. Right. Let's start with coming at it from the positive side. What's a number that is a little bit bigger than 2 that I could plug in and see what's happening to my y value?
2.0001.
At 2.0001, we're at over 37,000. So as you start to approach the number 2 from the right side, what's happening to the y value? Yeah,
Just going to pause infinity.
it's approaching infinity. That's what I'm looking for. All right. Let's do, as we approach 2 from the negative side, what would be a number I could test approaching 2 from the left? Yep.
1.999.
1.999, and we're at negative almost 40,000. So as you approach 2 from the left side, what's happening to the y value? Yeah,
Approaching negative.
it's approaching negative infinity. So when I ask you to investigate the behavior near an asymptote, that's what I'm looking for you to do. Now, I didn't investigate the other one. I did this one. X equals 2. But we could also look at -2 from the left and the right. Any question on that idea? Yes?
So you can look, can you only look at vertical asymptotes or can you look at any point?
Well, vertical asymptotes are the only ones that are going to go to infinity and negative infinity. If you look at approaching other numbers from like the left and the right that are not vertical asymptotes, you're not going to get this infinity and negative infinity behavior. But yes, you could still look at them. Yeah. Okay. So next couple we're going to look at are finding the EBM. So to find the EBM, it's just the highest degree term in the top divided by the highest degree term in the bottom. For the example, let's call this example 1. This will be example 2. What's the highest degree term in the top of example 1?
X squared.
X squared. What's the term that has the highest degree in the bottom for example 1? Yep,
X cubed.
x cubed. And if you simplify that as much as you can, what would be your expression? Yep,
1 over x.
1 over x. Generally, when you write an EBM, I don't usually see it written as an equation. It's written as an expression. It's a model. It's not an equation. So 1 over x. Okay, let's look at this one. What's the highest degree term in the top for example 2? Yeah,
X to the 4th.
x to the 4th. What's the highest degree term in the bottom? Yep,
3x to the 4th.
3x to the 4th. And when you reduce that EBM as much as you can, what do you get? Yeah,
1/3.
1/3. So in this one, on the one on the left, the degree in the top is smaller, and on the one on the right, the degrees are equal. What kind of asymptote would you get in both of these problems? Yeah.
Horizontal.
Right, you would get a horizontal asymptote in both. To find the horizontal asymptote, you let this number get really big and tell me what happens to that fraction. What would happen to this fraction if that part of it got really, really big? Yeah.
You would get smaller,
And it would approach
0.
0. So this would have a horizontal asymptote at 0. Now, same thing, if you look at this one and let the x get really, really, really big, what happens to the number in this box? Yeah.
Nothing.
Nothing. It stays at 1/3. So this would have a horizontal asymptote at 1/3. And anytime the degrees are equal, the horizontal asymptote is always shifted up or down, but it's still horizontal. When the degree in the bottom is larger, it's always at 0 because you're going to have an x in the bottom, always. And then the other case, when the top starts to get bigger, we already looked at that. That's when you get your slant asymptote. So the last one we'll look at, again, more of a technology question where we're going to find roots and local extrema. So if we're finding the roots, we're really trying to figure out where this equals 0. What's the only way that a fraction can equal 0? Yeah?
If you divide by 0? Or I mean, if 0's in the numerator.
If 0's in the numerator. So really, I only would need to set the numerator equal to 0. But what kind of equation is in the numerator?
Quadratic.
No, if it was a quadratic, it would be a lot easier to do by hand. Yeah?
Cubic?
It's a cubic, right? That's a cubic equation in the numerator. So in order for me to solve that, I would have to use rational root theorem, and maybe I'd get lucky, but probably not. So we're going to use the calculator to approach this. So let's start by finding the roots. Okay, so I've already typed in our problem. How do you find the root? What do we have to press? Yeah.
You do second calc 0.
Second calc, option 2, which is 0. And then make sure you pick a point to the left. Go to the right. Do your guess. And with that messy of an answer, I definitely know rational root theorem was not going to work. The only decimal answer we would get from rational root theorem using P's and Q's would have been a 5 over a 2 or a 1 over a 2. You would not have gotten a decimal that was 0.209355. So we had to use the calculator. Okay, so we've got our root. Now the other thing we want to find is local extrema. Does it look like there are any local extrema in that graph? What do you think? Yeah?
Possibly because it kind of flattens out a little bit in the middle, so it could be.
Yeah, we could zoom in a little bit. Like if you set your, I think if you set your y-min to like -4 and +4 for the max, I think you'll see it a little bit better. What do you think now? Is there a local minimum and maximum? Yeah, definitely. I can see a point where it goes down and then comes back up. So let's start with this one. Is that a local min or a local max? That is a local min. How do we find on the calculator a local minimum?
You can do on graph, I think it's second trace.
Second trace, yep. And then
And then option 3.
option 3. So pick a point to the left, pick a point to the right, do our guess, and there's our minimum. So the minimum is 1.10, and that occurs when x is -0.63. So if you filled in this number here, here, and there, you would get 1.1. That's what that means. Any question on that? So the minimum is 1.1. That's what it is. And it occurs when x is -0.63. Now, you'd have to do the other thing to find the maximum right there. You'd do second calc maximum. But there's something else that we know should be happening in this graph. And you just would have to know this based on what we've learned. What is the degree in the top? 3. And what's the degree in the bottom? 1. And that's a difference of what? 2. That means when I zoom out enough on my graph, I should be seeing a parabola shape. Do I see a parabola there? No, I'm only seeing the left half. The right half of this parabola has to be there somewhere. So we're going to try to find it by set our x max back to, oh, it's already at 10. Let's just leave it. Let's set our y max to like 400. So we can't see the local min and the max here anymore. Okay, that's really hard to see because we zoomed out. But we're not worried about that. That's why we zoomed in before. There's another local minimum up here. I'd say maybe it's at like 300 or so. Because I went to 400, that actually was too high. All right. Second, calc minimum. And just pick a couple points. So it's not hard to find it, it's knowing it's there. That's the problem. Okay. Any question on that one? Yeah.
What point would we write as like, if it asked for the answer, what would we write?
So if it said, what is the local minimum? I would say 231.46. If it said, where does that minimum occur? I would say when x is 6.05.
So the local minimum, like whatever it's asking for, we use y, and then if it, where it occurs, we use x?
Yes.
Okay.
What the minimum is the y. Where it happens is the x. Yep, exactly.